'Twas brilling, and the slithy toves did gyre and gimble in the wabe. All mimsy were the borogroves, and the mome wraths outgrabe. Hey everyone, those are the first few lines of a poem called Jabberwocky. Okay? And it was written by Lewis Carroll. It was included in his novel Through the Looking Glass in 1871. That's a sequel to Alice's Adventures in Wonderland, which he wrote in 1865. And believe it or not, we had to read this in math class one year because the author, Lewis Carroll, whose real name was Charles Dodgson, he was a pretty good mathematician and he liked puzzles. So we covered him in problem solving class. So thanks Dr. Colasar for turning me on to Lewis Carroll and some of that. But you know, my name is Dan Hansen. Welcome to another episode of Fun with Maps. So what does Jabberwocky have to do with fun with maps and having fun with maps? Well, it's one of the words in that poem that got to me, that made me think of it, and that's gyre, G-Y-R-E. Okay, so in oceanography, a gyre is it's a large system, any large system of circulating ocean currents, particularly those associated with large wind movements. Okay, it can be any vortex in the atmosphere, wind or water or in the sea, you know, even human created stuff, but it's mostly used, the word gyre, with terrestrial oceanography, and it refers to the major ocean systems. And there's 5 major ocean systems, notable ocean gyres on the planet. So there's the Indian Ocean gyre, there's the North Atlantic, the South Atlantic, and the North Pacific and the South Pacific. So the Northern Hemisphere, they flow clockwise, and the Southern Hemisphere flow counterclockwise. Okay? So this episode of Fun with Maps is about a region in the Atlantic Ocean. It's bounded by 4 currents. Okay? And these 4 currents form an ocean gyre. And what's cool is, unlike every other region of the world called a sea, this region, this sea, has no land boundaries. Did you catch that? Do you see what I'm saying? It's a sea, but it has no land boundaries. It's called the Sargasso Sea. Okay, so the Sargasso Sea is located entirely within the Atlantic Ocean, and it's the only sea in the world without a land boundary. So in this North Atlantic Ocean here, this sea breaks all the rules. No land boundaries, not even on one side, and it's the only sea in the world entirely surrounded by more sea. Okay, it's distinguished from other parts of the Atlantic and other oceans by this characteristic brown Sargassum seaweed, which we'll see pictures of, and very calm blue water. We'll see pictures in a minute. So in addition to giving the Sargasso Sea this unique geographical claim to fame, this area has great calmness, blue waters, great visibility. The water is transparent up to like 200 feet, so it's a popular area. The Fun with Maps fact, the Sargasso Sea was even part of, mentioned in Jules Verne's 20,000 Leagues Under the Sea book, so that's cool. Unfortunately, as we'll see, the stillness of the Sargasso's calm waters makes it a real trap for garbage. So there's about 200,000 pieces of trash per square kilometer in some areas, and they call that the North Atlantic garbage patch, unfortunately. So let's see what this unique sea is all about, this sea without borders, without land borders, in this episode of Fun with Maps. Okay, so here's the Sargasso Sea. Okay, here's North America, there's Florida, you can see Mexico coming around, Central America, South America, here's Africa, here's Europe, and here's the Sargasso Sea in the North Atlantic here. Okay, and see how the rotation is clockwise? That's because it's in the Northern Hemisphere, as we mentioned. So you know what a sea is. The sea, all the seas are connected as the oceans of the world. It's just a body of salty water. The seas cover about 71% of the Earth's surface, and you know, besides the oceans, we have second order sections of the sea, like the Mediterranean Sea or the Caspian Sea, something like that. Okay, but the sea, the ocean, whatever, and this is the Sargasso Sea. So it's bounded by, it's got the Gulf Stream here on the west, it's got the North Atlantic Current here on the north, the Canary Current here in the east, and here's the North Equatorial Current on the south. So what happens is winds blowing over the surface of the sea produce waves, okay? And the waves break when they enter the shallow water. And the winds also create surface currents through friction. So you get slow but stable circulations of water through the ocean. And that's what you have here from those four currents. Okay, here's another map. This is a world map, obviously. And you can see the red is the warm water, okay, and the blue is the cold. So here we have in the Sargasso, the Gulf Stream bringing in warm, and then when it leaves the North Atlantic, it's cold and comes back around and repeats. So we've got, you know, all over the world here. We've got the North Pacific and the South, and the South Atlantic, the North Atlantic, and the Indian. You know, these are the surfaces here. The direction of circulation, that's covered by many factors. You know, the shape of the continents, the Earth's rotation, which is something called the Coriolis effect, which is actually it's kind of a pretty heavy-duty scientific effect, so we don't have time for that or interest in that for this episode of Fun with Maths. But if you're into it, the Coriolis effect is pretty cool. So deep sea currents, you know, it's known as the global conveyor belt. They carry cold water from near the poles to every ocean. So we got the poles, it's coming down here. But what we're concentrating on today is this Sargasso Sea here with the Gulf Stream, North Atlantic, Canary, and North Equatorial. So we saw that the sea is bounded on the west by the Gulf Stream, on the north by the North Atlantic Current, on the east by the Canary Current, and on the south by the North Atlantic Equatorial Current. The four forming together are the boundaries, as opposed to every other sea which has land as a boundary, and that's called the North Atlantic gyres. So this is a NASA image where they kind of flip the colors. It's a false color image of the Gulf Stream flowing north through the western Atlantic Ocean. So again, to get us going here, here's Florida, here's the east coast of the United States in black here, okay? So this is the Gulf Stream, and it's coming, it forms the western boundary of the sea, okay? That's the Gulf Stream in this NASA image. It lies between 20 and 35 degrees north latitude, 40 degrees and 70 degrees west. It's approximately 680 miles wide by 2,000 miles long. So we'll see Bermuda is near the western fringes of the sea. But because the Sargasso Sea, it's bordered by oceanic currents, not land, its precise borders may change. It's not like there's a continent there to keep its borders the same. So here's a CIA map of North America, and you can see in this square here, in this little dot here, that's Bermuda. That's where Bermuda is, and in here we've got the Sargasso Sea that we're talking about. Okay, let's zoom in a little more on Bermuda. We're zooming in on Bermuda and the many islands that make up this country in the North Atlantic Ocean. So there's the capital, Hamilton, Bermuda's airport there, and we're going to talk about the Bermuda Triangle in a second. So the Gulf Stream is a major surface current. It originates in the Gulf of Mexico, then it goes through the Straits of Florida into the North Atlantic. It's kind of like a river within the ocean, and since it's like a river, it can carry and does carry floating objects. So its maximum velocity speed is about 6.6 feet per second. So remember this when we're talking about the Bermuda Triangle. If you're a small plane and you make a water landing, or your boat having engine trouble, you know, suddenly you've got this like a river in the ocean. It can carry you away from its reported position and maybe lead you to believe, or lead others to believe, that there's something mysterious going on. Another thing, when we look at you know, the mysteriousness of the region, especially the Bermuda Triangle, this is a track of all the Atlantic hurricanes between 1851 and 2019. So, okay, again, here's North America, here's South America. Look at all the activity here, all this hurricane activity. So if you're here in the ocean here, you've had a lot of hurricanes. If you're here in the Sargasso Sea, a lot of hurricane action by the Bermuda Triangle. It all makes sense. Things are happening there. A lot of hurricane action, okay? So the gyre has what's called a thermohaline circulation. So what that means, it brings salty water west from the Mediterranean. So here's the Mediterranean. It brings this salty water west, okay, and then north to form the North Atlantic deep water. And at the heart of this is the Sargasso Sea, and it's got still waters and this quite dense seaweed accumulations, as we'll see. So what makes it unique and cool and special, the Sargasso Sea is distinguished from other parts of the Atlantic Ocean by this characteristic brown Sargassum seaweed that you can see here, and it's often got very calm blue water. So these lines of Sargassum seaweed can stretch for miles along the surface, and it's clumps of floating algae. They're often concentrated by the strong winds and waves action that are associated with the Gulf Stream. So it's seaweed, the genus Sargassum. That's how we get the name Sargasso Sea, and it just floats there en masse on the surface. It's not a threat to shipping. When you hear things we'll hear about historic incidents of sailing ships being trapped there. No, that's more, as we'll see, it's due to the often calm winds of the horse latitudes there. And I should really digress here. Fun with maps fact: the horse latitudes are latitudes about 30 degrees north and south of the equator. That's the horse latitudes. And they usually have sunny skies, calm winds, very little precipitation. So the name probably came, you know, we've heard of beating a dead horse. So in this practice, the sailors they'd get a straw-stuffed effigy of a horse and parade it around before throwing it overboard. So, because the seamen were usually paid at least partly in advance before a long voyage, and a lot of them spent all their money at once. So there's a period of time without any income. So if they got advances from the ship's paymaster, they would have debt then. So this period of time was called the dead horse time, and that could be a month or two. So when they paid off the dead horse debt, the seamen would have this ceremony and you know, toss the effigy of the horse into the ocean. So as westbound shipping from Europe usually reached the subtropics at about the time the dead horse was worked off, the latitudes became associated with the ceremony. So those are the horse latitudes. This is a close-up of a small mass of the Sargassum weed. This is what's floating there in those long lines there. That's Sargassum. They've got all these little round spheres and floats, and that's filled with carbon dioxide, and that's why they provide some buoyancy to the algae. So that's why they're laying on top of the ocean there, because of these little spheres that float full of carbon dioxide. Here's another close-up. You can see, you can really show those like air bladders here. They're filled with carbon dioxide, and keep the algae afloat, and have those long lines of brown sargassum. Nature is so cool. Okay, so we've got these fish know to camouflage themselves in the sargassum and adapt to live among this drifting sargassum seaweed. So over here, there's actually two here. This is a camouflage sargassum fish. Okay, And you can see the guy's hand to give you some sense of scale. So they're pretty small. That's the Sargassum fish. And this is a juvenile puffer fish. And that's also found in the Sargassum. But you can see how well camouflaged they are. If you saw these in the Sargassum, you would never be able to detect them. And it's also believed that after hatching, young loggerhead sea turtles will use the currents of the Gulf Stream, travel to the Sargasso Sea, and then they use the Sargassum seaweed as a cover from predators until they are mature. So again, nature's just so cool. So all of the currents deposit the marine plants and refuge which they're carrying into this sea, but the ocean water in the Sargasso Sea is distinctive for its deep blue color and exceptional clarity. In fact, you can have an underwater visibility of up to like 200 feet. And because of all this, because of its uniqueness, it's really captured the public imagination, and it's in all kinds of literary and artistic works and in popular culture. So in fact, here's a fun with maps fact. The first known written account of the Sargasso Sea dates 1492. You know who that is? Christopher Columbus. He wrote about the seaweed. He thought it would trap his ship and potentially hide shallow waters and they'd run aground. And he was afraid of that, so he wrote about these the Sargassum weed and the Sargasso Sea. And historians think the sea may have been known to earlier mariners. There's a poem by a late 4th century author who described a portion of the Atlantic as being covered with seaweed and windless, and many think this was the Sargasso Sea. So if you were a mariner and you came across this, you know, it's so unique, the calm blue waters and this line of seaweed. That's the Sargasso Sea. Unfortunately, the gyre, you know, it does good stuff, but it traps a high concentration of non-biodegradable plastic waste, and it's a natural garbage or flotsam patch. Same way the North Pacific gyre has the Great Pacific Garbage Patch. And several nations and non-governmental organizations have united to protect the Sargasso Sea, including there's the Sargasso Sea Commission which was established in 2014 by the governments of the Azores, or Portugal, Bermuda under the United Kingdom, Monaco, the United Kingdom, and the United States. So here's a fun with maps fact. The United Nations Environmental Program estimated that for every square mile of ocean there are about 46,000 pieces of plastic. Let me repeat that. For every square mile of ocean, there are about 46,000 pieces of plastic. And the 10 largest emitters of oceanic plastic pollution worldwide are, from the most to the least, China, Indonesia, the Philippines, Vietnam, Sri Lanka, Thailand, Egypt, Malaysia, Nigeria, and Bangladesh. So that's largely through their rivers, which they dump the plastic in their rivers, like the Yangtze, the Indus, the Yellow, the Hai, the Nile, the Ganges, the Pearl, the Amur, the Niger, the Mekong. And that's how 90% of all the plastic that reaches the world's oceans are from. So Asia is the leading source of mismanaged plastic waste, and China is the major perpetrator here. China alone accounts for 2.4 million metric tons. So it's great, you know, keep recycling and keep those plastic bottles and all out of the environment, but we got to look at these 10 largest emitters, and they're just not doing their part. So as we said, the Sargasso Sea here, it's often portrayed in literature and the media as an area of mystery. People think, you know, it's a dangerous area and ships are mired in the weed for centuries, unable to escape. Of course, we've all heard of the Bermuda Triangle, okay, which we've got overlapping here with the Sargasso Sea. And, you know, reportedly all kinds of mysterious things have happened. Ships have disappeared and people have disappeared, and in fact, in reality, the facts say the number of ships and aircraft reported missing in this area, the Bermuda Triangle area, is not significantly greater, proportionally speaking, than in any other part of the ocean. Okay, so we've got this triangle here. If you took another triangle somewhere, proportionally it would be same amount of missing ships and aircraft. And in an area frequented by tropical cyclones, the number of disappearances that did occur were, for the most part, neither disproportionate, unlikely, or mysterious. So we saw that map with all the hurricanes there. They were all congregated in here, just so many over the last 100 years or so. That's what's happening there. It's nothing mysterious. It's not, scary, mysterious area of the Bermuda Triangle here. In fact, here's a fun with maps fact. It is fun to talk about, though. But the sea is, the Sargasso Sea is so unique that it leads to people developing mysteries and stories about it. So, like in July of 1969, there's this British amateur sailor named Donald Crowhurst, and he disappeared after his yacht became mired in the Sargasso Sea. Okay, he had been competing in the Sunday Times Golden Globe race, and now it's a single-handed round-the-world yacht race. But he had a poorly prepared boat, and it began to take on water. So he quit his attempt to circumnavigate the globe, but he kept reporting false positions by radio because he wanted to give the impression he was still participating. Eventually, Crowhurst, he drifted into the Sargasso Sea, and he just kind of deteriorated, mentally and physically, and he wrote all kinds of delusional stuff in his logbooks. And in his last entry, they found his yacht unoccupied and drifting about a week later, and people still don't know if it was the result of suicide or misadventure, but they love to speculate this area of the world because the Sargasso Sea is so unique, and there have been some incidents in the Bermuda Triangle, even though it's not more than any other proportionate area of the oceans. People love to talk about it, but there's nothing mysterious going on there. And hast thou slain the Jabberwock? Come to my arms, my beamish boy. O frabjous day, Callooh, Calais, he chortled in his joy. So I don't think I'll ever be able to think of the Sargasso Sea without thinking of Jabberwocky by Lewis Carroll. Both are really cool, and you should check it out. If you're ever on Jeopardy or another quiz show, you'll be able to answer, what is the only sea in the world that has no land boundaries? And that's our Sargasso Sea, the topic of this Fun with Maps. So I hope you enjoyed this episode of Fun with Maps. I sure did. If you did, please click like and consider subscribing so you never miss an episode. Until then, I'm your host, Dan Hansen, and keep on having fun with maps.